Hello everyone, and welcome to week 2. This is Dr. Mo, and I will be recording a tutorial for your second week assignment. So if you go to your Excel spreadsheet and click on the tab that says week 2, let's look at what we have to do here. Now we're going to examine the salaries some more and look at any differences between gender, and also we'll look at the impact of education with the data we have. So let's start with question 1. So here we want to look at salary variation within the groups. So essentially, in other words, we want to check if the variance of salaries within the female group is equal to the variance in salary within the male groups. So you want to tell if the variability in one group is different from the other group. So in order to do that, we want to perform a hypothesis test. Remember, all the data we have is sample data, and in order to infer anything about the entire population, we have to perform hypothesis test, because the sample is random, and if I pick a different sample, I could get different results from the sample. So we need to be sure that our conclusions are valid. We have to perform a hypothesis test. So what data is needed for this question? Well, we need the salary and gender. So we'll go back to our data tab and get again the salary. Let's put it in column X. And we will need the gender, which is right here. Let's pick gender 1, so we know male and female. Let's put it here. And once again, we need to sort this to make sure that we have female separate from males. So we're going to go sort, custom sort, and then we're going to sort by gender 1. So now we have our split, so we have the females on top and the males on bottom. Very good. So here's our data, so you're just gonna write that the data is in columns X and Y. Okay, so what is needed for this question? Do we need a one tail or two tail? Well, given that we're not interested in testing if the variability is in one group is larger than the other, we just want to know if they're different, then we need a two-tail test. Okay, so what's going to be our null hypothesis? Well, the null hypothesis is going to be that male and female have salary variances that are equal. And the alternative is going to be the opposite, that male and female have different variance in their salary. Okay, so what type of test can we use to determine if we can reject the null or not? Well, the type of test we use to check variances is called the F-test, and we're going to use the F-statistic. So that's what you need to type here. And let's say our significant level is going to be 0.05, so that's our alpha. So we're going to compare our p-values to 0.05. So what's the decision rule? Well, we're going to reject the null hypothesis if we get a p-value less than 0.05. Okay, so we can type this. Okay, so now we need to conduct the test. So we're gonna go to again our analysis toolpack. We're gonna select F-test, to sample for variances. Our first data is gonna be the males, and then our second variable is gonna be the females, and we press OK. So, and this is the result we get for the test. We just copy it and paste it. This saying paste it in K10, so K10 is right here, so I'm just gonna paste it here. So here we go. So this is the result of the f-test, but notice that Excel performs f-test only one tail. Okay, so what do we need to do? Well, we need to take this p-value and multiply it by 2 because we're conducting a two-tail test. So we have this p-value times 2, so we can say, so here's our test, and then what's the p-value? We can say is equal to 2 times this value right here. So that's our p-value, 0.69. As you can see, the p-value is larger than alpha, so we can't reject, because we said we're only going to reject if p is less than 0.05. When we got p that's higher than 0.05, we cannot reject the null. And our conclusion then is that if we can't reject the null, then we have to accept it and conclude that equal variances in male and female salaries. So both of the groups have equal variances in salaries. Of course, I expect you to fill up everything in here based on what I just did. Now we go to the second question. Once we know about the variabilities, that they're equal, we can test the average salaries. Okay, so we want to compare the mean salary for male versus mean salary for female, and again we want to test if they're equal or not. We don't want to test if males are making more than females at this point. We just want to test equality. So what test are we going to use? Well, we're going to use a t-test in that case, and our null hypothesis is that male and female are equal, and the alternative is that they're not equal. Again, our alpha, we stay at 0.05. Your test statistic is a t-statistic and t-test because we're conducting a t-test. And why we're selecting this test? Because we're comparing means. Okay, we're testing the difference between two groups. And our decision rule, we're gonna again reject the null, so we can copy this. Reject if p is less than 0.05. So that's gonna be our decision rule. So let's conduct the test now. So we go to data analysis, and now we're going to conduct a t-test assuming equal variances. Remember, we just proved that the variances are equal, so we can use this test. Press OK. So our first group is a male, our second group is a female, and press OK. And here are the results of the test. So again, we take this and we copy it to our worksheet. So let's say use cell K35, so we can paste it right here. And again, we highlight the p-value. Remember, here we're doing two-tail test, so that's the p-value that we're looking for. And as you can see, this value is less than 0.05, so we're going to conclude that we can reject the null because the p-value is less than 0.05, so it meets the decision rule. And we can conclude that there is a significant difference between male and female salaries, between the two population means. So we don't know yet who's making more, but we know that there is a statistical significant difference between both groups. Okay, question 3 asks you to look at the effect of education. So we want to compare employees with advanced degrees to employees with undergraduate only. Okay, so let's go back to our data. So now we need salary. So I'm gonna need salary education. So here's salary. This time I'm not gonna copy gender, I'm just gonna copy degree right there. Now I'm gonna sort one more time. This time I'm gonna sort by degree because I want to split them into two groups. One group with advanced degree, which are the ones marked with 1s, and one group with only undergraduate degree, which are the one marked with 0. Okay, so now that we have our data ready and split into two groups, we can go ahead and conduct the test one more time. So here, the difference between this test, we're still going to conduct a t-test because we're comparing means for the two population, but this one we want a one-tail test because we want to test whether or not employees with advanced degree have a higher average, not just a different average salary, but a higher average salary. So that means it's a one-tail test because our null hypothesis now is average salary for undergraduate degree greater or equal to average salary for the graduate degree. And the alternative, which is what we were looking to prove, is that average salaries for undergraduate is going to be less than average salaries for graduate. So if we can prove that we can reject the null hypothesis, then we will accept the alternative hypothesis and conclude that yes, indeed, people with undergraduate degrees on average make less than people with graduate degrees. Again, we're going to select our alpha to be 0.05. Test statistic is a t-test, one-tail t-test. Why? Because again, we're comparing means, and the decision rule once again is going to be reject if p is less than 0.05. So let's conduct the test. So we'll go data analysis. Again, 2 sample, assuming equal variances. This time our first group will be people with undergraduate degrees, and our second group will be people with graduate degrees. And that's it. We copy that. That goes into K60. And this is a one-tail test. So here we go. This is the p-value we're interested in. Make sure you highlight it as well. And we conclude that p-value is not less than 0.05. So we don't have enough evidence to reject the null hypothesis. So if we don't have enough evidence to reject the null hypothesis, then we conclude that actually there's no significant difference between people with advanced degrees versus people with undergraduate degrees in this company. So education or degrees does not seem to be a factor impacting salaries. Okay? And then once again, based on everything we did, we expect you to come up with a conclusion. Make sure you, before you start this assignment, to read the lectures carefully, because they will guide you as to how to build your conclusion. I answered everything for you. All you have to do now is just go back and do it. Make sure that you have your formulas everywhere, like I did here, and explain everything in detail. Good luck, and if you have any questions, make sure to send me an email.